Good morning. Welcome to IMS 2019. I'm George Solomon for Communication and Power Industries. Today we're going to talk about solid-state amplifier power combining. Give you some tips on what we do to select different technologies for different power combining. So from power combining, size matters. What we like to have is a very low loss, very efficient power combiner. The combination of the combiners will be for graceful degradation. We'll have isolation between the combiners and or circulators on the combiners. Trades for the different approaches. The first trade is a non-reactive combiner, which has internal loads and a graceful combiners, and then the second one is a reactive combiner with isolators. And the trades have to do with the isolator combiner. You add the additional losses of the isolator on top of the combining losses, which makes it a little lower in power. But both are effective for graceful degradation. In CPI, we design our hybrids and combiners with air strip line, air coax, waveguide, depending on the technology and the power required. Ultimate goals are low loss, high power handling, and the key to low loss is the largest conductor you can use to get the efficient amount of power out of the module. And in graceful degradation, when you look at turning on multiple SSPAs into modules, you can take 12 modules and shut off one module, and you're only going to lose about 84% of you're only going to have about 84% of the power. So if you have a 13 kilowatt amplifier with 12 SSPAs, one module down, 11 over 12 squared, will give you the power of about 11 kilowatts. In our power combiners, we use, in one case, a radial combiner where we select the output to be 7/8 coax, and we do a radial approach with a graceful combiner with power and loads. And the trick with these combiners is really to match the power and the load for the combiners such that the loads will be able to handle the power with any combination of SSPAs turned on or off. Additional ways we do combining is with a four-way power combiner or a reactive in-phase waveguide combiner. When you look at combining efficiencies, one of the things you need to look at is both amplitude and phase combining. Your amplitude imbalance, when you look at your amplitude imbalance, you can have a difference of a half dB, and you're only going to lose about a tenth of a dB in combining losses. The phase is a little more tricky. You need to be within 5 to 10 degrees for optimum power combining, but you can be off 20 degrees and still be within a tenth of a dB in your optimum power combining. So when we start looking at power combining in systems, we look at what is the biggest combiner we can have for the application. We start from the output of the combiner for the maximum power, and the design considerations we look for both low loss structures, isolation between the individual ports, and to be able to handle the mismatch from both VSWR and arcing. So the power handling, when you look at devices, you want to have the maximum conductor for the lowest loss. The minimum amount of isolation you want is 15 to 20 dB. You also need to consider what the ambient pressure is for in the case of arcing for different modules. So hopefully that was helpful. If you want to come talk to us, we're at booth 449, or come see our website, cpii.com. Thank you very much.